Hello dear student, welcome to my YouTube channel. In this video we will see IUPAC Nomenclature. We will see the class that is alkane, alkene, dienes, alkynes, alcohols, aldehydes, ketone, amides, amide, phenols, alkyl halides, carboxylic acid, esters, acid chlorides and cycloalkanes. So these are some classes that we will see and collectively an example. Firstly, understand that what is this IUPAC nomenclature or IUPAC nomenclature. I, it stands for an international. It stands for an international. U, it stands for an union. P, it stands for an pure. A, it stands for applied. And C, it stands for chemistry. It is a union of international union of pure and applied chemistry. See, everywhere in the world, any compound, it should be named as per this rules, set of rules. It is made by this IUPAC nomenclature. We will see one by one compounds. There are certain functional groups. First thing is that every functional group, it has a priority. It has a prefix, it may have a prefix or it will have a suffix most of the time. So starting from a carboxylic acid, when we have to name any compound, or from the structure we have to name a compound, or from the name we have to write a structure. In that case, first rules that you should know what is the priority of that functional group. So very first functional group, that is carboxylic acid. If you write a structure of a carboxylic acid, it is C double bond O H. It is having H at the end, and in the prefix, as usual, no, there is no prefix for an carboxylic acid. If it is so, because it is a principal functional group, it has a priority number 1, and in the suffix it is called oic acid. One by one we will take an example of each and everything. Next is anhydride. The structure of an anhydride is like this. In between it is having an oxygen link, and from both the side it will have a carbonyl functional group. In the prefix it is nothing called, in the suffix it is called oic anhydride. Only acid and anhydride, the name has been changed, but the remaining thing, that is oic anhydride, it is same. Now next functional group, that is ester. So instead of this H, it will have a R. It will have a R. And that R, see that R, it will be an alkyl, and alkyl after that it will be having a suffix, that is OAT. It is having the suffix OAT. Next is acid halide. Instead of this OH or OR, in case of ester and carboxylic acid, it has been replaced with the help of an halide, and that is called oil halide. Oil halide. Next is amide. Amide, it is, instead of this chlorine, it will have a NH2. In the prefix it is called amido. In the prefix it is called amido, and in the suffix it is called amide. Dash amide. The remaining will be the name. Next is nitrile. It is written in this format: C triple bond N. In the prefix it is called cyano, and here it is called nitrile. Next is aldehyde. So aldehyde, it will have a hydrogen attached to the carbonyl functional group. Instead of OH or 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 Cl or NH2, it will have a hydrogen. So in the prefix it is not having any name, and in the suffix it is called Al. Al. Next is ketone. So ketone, instead of hydrogen, it will have a R functional group. In the prefix it is called oxo. It is called oxo, and in the suffix it is called -one. The structure of an alcohol, it is ROH. In the prefix it is called hydroxy, and in the suffix it is called OL. Thiol, that is SH, bond SH. In the prefix it is called mercapto, and in the suffix it is called thio. Amine, next is amine, RNH2, so it will be an alkyl amine, any kind of an alkyl amine. In the prefix it is called amine, and in the suffix it is called amino. Now the ether, it is having oxygen attached to two alkyl groups. In the prefix it is called, in the suffix it is called ether. Next is alkyne. So it will have a double bond, alkyl will have a double bond, and here it will have a hydrogen. So in the suffix it is called ENE. Alkyne, it will have a carbon-carbon triple bond, and in the suffix it is called YNE. Next is alkane. So here alkane, in the suffix it is called ANE. And halide, lastly halides. So in the prefix they are having a name. So it may be chloro, bromo, iodo. So chloro, bromo, iodo, or there is one more, that is fluoro. So these are some of the names of an functional group and the priorities which has to be written in the prefix and suffix. It depends on certain rules. So what are that rules? First, that we will see. There are rules of a nomenclature. Identify the longest chain of an carbon. By example, we will understand it. These are the rules. Identify the longest chain of an carbon atom. The carbon chain with a functional group, that has to be considered. Number the chain. And when we number a chain, the lowest possible number to the principal functional group, that has to be written. Next is identify the substituents. If it is having an alkyl kind of a substituent or halogen kind of a substituent, that has to be identified. After that, prioritize the functional group. So use this table for a priority purpose. Use the highest priority functional groups as a suffix, and lower priority functional group as a prefix. So prefix, always it is written, like suppose this is the word, any word. So prefix, it means it is written over here, prefix, and suffix, it is written at the last of any word. Assemble the name and prefix, name the substituents in alphabetical order. It is very important. Understand that when we write a prefix, it should be in alphabetical order with their position numbers. The parent is the base name on the longest chain, as we are selecting the longest chain, so that will be the parent name, and suffix, it will be the functional group based on the priority. If there are two functional groups, we have to select the priority, which priority the functional group it comes. We will understand it with help of an example. The first example that we will see. First rule is that as per the IUPAC nomenclature, rules of IUPAC nomenclature, select the longest chain. There is no branching, it is very easy example. And there is no functional group. So you can write numbering from any side, 1, 2, 3, 4. This is also correct because there is no numbering. There is no any kind of a functional group. You can write number from any side. So this structure, it is of a butane. As it is alkane, it has to be written ANE, butane. Now this structure, it is very similar, but it is having only a double bond in between. But if we calculate a double bond 1, 2, 3, 4, we can see that from both the sides it is on the same number. It is on the same number, so there is no need. Anyone can be taken into consideration for a numbering. So first is that select the longest chain. There is only a chain, straight chain, and later on number should be such that the functional group, it should be closer. Now in this case, on both the sides, numbering it is at the same carbon, that is carbon number 2. So put a 2 in the prefix, put a dash, and then a number, the name of the carbon, that is butane. But only the problem is that you have to replace ENE instead of this, because it is having a double bond. In the prefix we have written 2, but in the suffix we have to write ENE. So that is for an alkene. Now for an example, this is one more example from the same class. Select the longest chain. So this is the longest chain because there is no branch. Longest chain. Now number the longest chain. 1, 2, 3, 4, 5. If we start numbering from this side 1, 2, 3, 4, 5, we can see that possibly the carbon number 2 is having the least possible number for a functional group. So this is correct. This cannot be a correct because we have to find out the least number for the functional group in this carbon chain. So 2 is correct. This numbering it is wrong. Above numbering it is correct. The name of the compound, as it is a pentane chain, so first for a double bond it is 2 because double bond it is located at carbon number 2, PEN-T. A and E should be replaced by E and E because it is having a double bond. There are 2 examples in this case. We will solve this one example. Firstly, select the longest chain. There is no branch. So the longest chain it has been selected. Now start the numbering. For numbering, find out the functional group where it is located. In this case, there is a alkyne functional group which is present. 1, 2, 3, 4, 5. We have selected the longest chain and numbered it. Now the number of carbons, they are 5. It means that is a chain of an pentane, parent chain of an pentane. So I will write PENT, and at the last C, A and E should be replaced by Y and E, and the location of a double bond it is at the first carbon. So the name of this compound will be 1-pentane. Now the next example where the carbon chain it is similar, numbering will be also similar, but there is only a double bond. This is the longest chain 1, 2, 3, 4 and 5. At carbon number 1 there is a triple bond and carbon number 2 there is a double bond. Now how to write such kind of an examples, name of such kind of an example. As we know, there was a pentane, YN, it means that it was alkyne. Now there is also an alkene, it is having a double bond. So in this case you write PENT. After that, so this double bond it is located at position number 3. So put here 3 and dash. Now write EN. Don't write E further because that has to be replaced by YNA. And the triple bond position it is at 1. So write 1 YNE. So this is how you have to solve the example. Next example it is of a diene. Diene means there are 2 double bonds and ENE, that is alkene. That is why it is called diene. Here we are having an example. So the first task is to select the longest chain. The longest chain it will be because there is no branch. Now number it. We can number it from both the sides. As we can see the double bond it is closer to the functional group 1, 2, 3 and 4. It can be numbered by this way also because the numbering for a double bond it will be same by both the sides. There are 4 carbons. It means it is a structure of an butane. Parent compound it is butane, and there are 2 alkene groups. So this alkene groups or double bond they are at position number 1 and position number 3. So it will be diene. Di because there are 2 double bonds and ENE it is for a double bond. Now the collectively the structure can be written as 1, 3 dash buta. In that case only replace NE. Don't replace ANE. Just replace NE. In that case A is written. Whenever there is 2 functional groups, like in case of an alcohol there will be a 2 functional group diol. So for that purpose we have to retain the A. and further structure will be dine. The name of this compound it is 1,3-butadiene. Next class it is of an alcohols. First select the longest chain. So there are 3 carbons. It will propane. It is a basic compound, that is propane, and it is having a hydroxyl group, that is alcohol. So it can be written as propanol. Just replace E by OL because it is having an OL, and the location of it is at number 1, at carbon number 1. OH it is at carbon number 1. So we need to write 1-propanol. Write this P in a capital form. 1-propanol is the name of the compound. Now next is aldehydes. In case of aldehyde, again select the longest chain, see number of carbons. We have to number it from this carbon 1, 2, 3 and 4 because this is the functional group carbon. In this case, the parent compound it is butane, and it is having a suffix of an aldehyde, that is suffix it will be Al, and the name of compound it will be butanol. You can write 1-butanol also if because aldehyde they are always at the end only. If you don't write an 1-butanol, then also it is correct. If you write, then also it is correct. One important thing to note is that when we write the name of the compounds, consider the functional group carbon also in that case. Don't only take only this chain of an propyl. Consider this functional group carbon, so it will become an butane. Next class that we will see it is a ketone. See, there are 3 carbons, 1, 2 and 3. It can be numbered from any side because the carbon or the carboxy carbon it will be at number 2 only. It is a chain of an propane, basically propane, and when we write a ketone, so at the end replace E by ONE. So the name of this compound it is propanone. Just replace E in the propane and write ONE. Now there is one more example. See, when it is written in the suffix it is written on. Now we are having a ketone and aldehyde functional group. The parent or the principal functional group it is an aldehyde. So the numbering will start from this side 1, 2, 3 and 4. There is a chain of an carbon and there are 4 carbons. It means it is the structure of an butane, basically. Parent it is a butane. In the prefix, the ketone it is called oxo. It is called oxo in the prefix. And in the suffix we are having one more functional group, that is an aldehyde. So aldehyde it is called Al. Now we will write a name of the structure. See, this oxo it is at 3 number position, so 3rd carbon it will be and ketone containing functional group. Name of compound it will be 3-oxo, and further it will be butanal. Just replace E and write it by NaL. The name of the compound is 3-oxo-butanol. Further class is amine. In case of amine, when it is prefix it is written as amino, and when it is at suffix it is written as amine. Like this example, it can be written as there are 2 carbons, it means that is an ethyl. So it will be written as ethyl amine. The basic structure it was of an ethane. Only replace that ANE by YIL because it is containing not all the hydrogen. That is why it has been replaced by ANE. And the further we are having a compound that is an amine having a nitrogen. Further class is amide. Now in this case we have to consider the functional group carbon also. There are 2 carbons, so the basic structure it is of an ethane and further structure it will be of an amide. So at the suffix end we have to write an amide. The name of compound it will be ethanamide. Just replace E. Just replace E in that case. Everywhere we have seen that we have to replace E and write the further structure. So the name of this compound, it will be an ethanamide. Example that we will see. First rule is that select the longest chain. When we select the longest chain, see, this is the longest chain that we have selected because there is no other branch, so it is very easy to understand. Now there is a functional group. It is a carboxylic acid, and here it is alkene. So select the numbering or give the numbering to the principal functional group. It will start first 1, 2, 3 and 4. So these are the 4 carbons. As in the actual, if it is alkane, so the name it will be butane. We will collect the name. Every name we will collect. So this will be the parent name, that is butane. After that, in the prefix and in the suffix, what we have to write? So this, it will be a parent name. Now the next is, once you select the longest chain, number it, then find out the substituents which are present. Here the substituent, that is an alkene which is present. So alkene is a substituent. So in the prefix, we have to write an alkene, and it is at a second number. So it is alkene in the second number. Now the next thing is the principal functional group in this molecule. The principal functional group in this molecule, it is the carboxylic acid. So it has to be written in the OIC as a suffix, OIC acid. Now we will collect the name. So the name of this compound, it will be, see, I will write one by one. BUT. Now we can see that the substituent of a double bond, it is present on the second carbon atom. So write a number over here, put a dash, 2, butane. It should be replaced with the help of an E. It should be replaced with the help of an E. So I will replace it. And N, and last E of the parent name, that should be replaced with the suffix. So here suffix is OIC acid. It is OIC acid. So I will write here IOC acid. So the name of compound, it is 2-butenic acid. Butenic acid. E, it represents the double bond at carbon number 2. IOC, it represents a carboxylic functional group. And 2, it represents that this double bond, it is present at second number position. There is no need to write the position of an carboxylic acid, as because it will be always at the first priority, and it will be placed at always the first position only. So there is no need to write a mention 1. So the name of this compound, it is 2-butenic acid. Next example is, say, firstly we have to select the longest chain. So this is the longest chain. Find out the principal functional group where it is. So in this case, aldehyde is the principal functional group. So I will number it from 1, 2, 3, 4, 5. I cannot number from this side because principal functional group, it is present on the right hand side. Now we have selected the longest chain, we have numbered it. Find out the parent. What is the parent carbon chain? 1, 2, 3, 4, 5. So there are 5 carbons. So this structure, it is of an pentane in the parent, and we have to replace it by prefix and suffix later on. See, there are 2 functional group. One is ketone, but that ketone, it is the less priority functional group, as we have seen in the table earlier also. Aldehyde will have more priority because the priority of an aldehyde, it is more than an ketone. So ketone, in the prefix, it is called oxo. So this is prefix of an ketone. In the prefix, it is called oxo. Now the next is aldehyde. Then aldehyde, in the suffix, it is called Al. Al. Now see how we have to write the name. We will collect the name. See, there are 5 carbon. So the basic structure it was of an pentane. I will just write pent, ANE. ANE it will be written later on. See, firstly we will write a prefix. So prefix it is at an 3 number. So it will be 3-oxo. 3-oxo PENT. Because there are 5 carbons. AN. Only E has to be replaced. In that case, only E has to be replaced. So it will be pentanal. 3-oxo-pentanal. It will be the name of the compound. So it can be written like this like this manner. See, 3 after that dash. Any number that has to be written after dash. After that, use a alphabet, capital alphabet, oxo, and remaining you can write in a small letters. The name of this compound is 3-oxo-pentanal. As per the rule, select the longest chain. So this is the longest chain that has been selected. Now number the functional group. Very important thing is, when we are numbering this carbon chain, see the principal functional group, the location of the principal functional group, and it should have the least position. So numbering will start from this 1, 2, 3, 4, 5, 6. So there are 6 carbon. It means that it is an heptane molecule. So hexane molecule. It is an hexane molecule. Now the hexane molecule, a carbon chain of an hexane. In the prefix, this is the parent, and in the prefix there are 2 substituents. Identify the substituents. So the substituent it is present at 3 number position and 5 number position. So first it will be 3-methyl, that I will write, and the next substituent is amino. So it is at an 5-amino. So these are prefix. Now we have to identify the suffix. So suffix it is an carboxylic acid. So it is oic acid. So hexane. Now we will complete the answer by writing the prefix and suffix. He. So I will write here HEXAN. Replace only E. Replace only E by ioic acid. Hexanoic acid, name of the compound. Now we have to write the prefix. So when we write a prefix, don't arrange in the form of a number. Arrange in the form of an alphabetical order. It does not mean that 3 it comes first, that has to be written firstly, or 5 it comes later on, so it should be written later on. So arrange the functional group or the substituent in the form of an alphabetical order. So A will come first, then M will come later on. So it will be 5. Right, put a dash, 5, write first word capital, first letter capital, amino. Again put a dash, 3. We have to write a number from both the sides, put a dash, 3-methyl. Hexanoic acid. So this prefix has to be written in an alphabetical manner always. The name of compound it is 5-amino. 5-amino, 3-methyl, hexanoic. Only E has been replaced and remaining that is oic acid. The name of compound it is 5-amino 3-methyl hexanoic acid. The next example, select the longest chain. So this is the longest chain. Up to this carbon only we have to consider the chain, not this carbon, because it is after the functional group. Here ester is the functional group. There are 4 carbons, 1, 2, 3, 4. That has to be only considered, not after the functional group. There is one substituent, that is hydroxy. So I will write the parent chain. What is it? It is of an butane. Parent chain it is of an butane. Now prefix. Which are the prefix? Firstly number it 1, 2, 3, 4. Numbering will start from the principal functional group as per the priority rule. It is an ester. So 3-hydroxy. It should be 3-hydroxy alcoholic. In the prefix it is called 3-hydroxy. Now the suffix. What is suffix? In the suffix you can see that it is having a ethyl chain. So that ethyl chain, it should be also written in the prefix only. Only the functional group it is ester, but it is having ethyl chain of an ethyl chain. So that has to be written in the prefix, and in the suffix it has to be written 8. So it will be 8. Now we will see the collectively the structure, what has to be written. I will write only BUT. And now we have to write the prefix. So when we have to write the prefix, see, it should be in the alphabetical manner. Ethyl will come first. There will be no number for an ethyl because it is on the functional group. So it has been understood that it is on the first number. So it will be one ethyl. It will be only just write ethyl. And after that put a dash. Again put a dash. Hydroxy. So it has been understood ethyl 3-hydroxy, and the next is BUT. A and E, only replace E from it, and then it will be butanoate. Here it is O8, actually I have written only ATE, OATE, it is butanoate. So the name of this compound, it is ethyl. So this is the ethyl, and after that 3-hydroxy, it was a substituent present on it, and butanoate because there are 4 carbons, and at the last it is ester. Next class it is of an phenols. In case of phenol, this is the structure of an phenol. We shall number it 1, 2, 3, 4, 5, 6. Here numbering it is, we can write it from right hand side and left hand side also, because there is no substituent present. When we write a numbering, the numbering it should be closer to the functional group. Like in this case 1, 2, 3 and 4. The numbering it is same from both the side, 1, 2, 3, 4 and 1, 2, 3, 4. So this, in this case there is we can write a numbering from both the sides. Now we will write the name of this structure. The phenol, it is a common name, and see it is having a position of an substituent at the 4th position, that is chlorine. So it will be 4-chloro because chlorine it is at 4th position, and in the prefix it is written as chloro, 4-chlorophenol. This is the name of compound. Now there are 3 chlorine groups. Again we will number it 1, 2, 3, 4, 5, 6. There are 3 chlorine. It means that it becomes tri, and we have to write a number at which position the chlorine it is present. 2, 4, 6. 2, 4, 6 trichloro phenol is the name of a compound. Now in this case there are, instead of chlorine we are having a methoxy functional group. So methoxy, again we have to number it 1, 2, 3, 4, 5, 6. We can number it from this way also because chlorine it will be at same position and methoxy will be at the same position. Now write the name of the compound. See there are 3 substituents which are present. Out of that chlorine it is same. So it should be written as 2,6 dichloro 4-methoxy. You can put a dash on both the sides of a number, methoxy phenol. Now one thing here is to mention that when we write this chloro, C it comes first and then comes an M. It should be written in alphabetical manner. If there is any compound which comes earlier than C, that has to be written in the alphabetical manner. It does not depend on the number. If the number of the chlorine it is 2, it does not mean that has to be written in the first. It depends on the alphabetical manner. So C come first, that is why we are writing the C. Don't consider the like di, tri or tetra. This prefix don't consider for writing in an alphabetical manner. Only consider the name of a functional group. That has to be considered during writing in an alphabetical manner. There are few examples of an cycloalkanes. See, these are the cyclic structures of an alkanes. Now we need to write the name of this compound. See, there are 3 carbons at the 3 corners because it is a triangle. So it will be a chain of 1, 2 and 3. because there are no substituent, I can write numbering from any side. 1, 2 and 3. So it will be a chain of an propane, and the compound name it should be written cyclopropane. So cyclo it should be written in the prefix and we get a name of a compound. Similar way, there are 4 corners, it means there are 4 carbons. The structure name it will be butane and it will be cyclobutane. And in this case there are 5 carbons adjacent. So this is the structure of an pentane, and in the prefix we have to add cyclopentane. When the structure it has been having such kind of an, like for an example, it is having a substituent. So the substituent, now here is a methyl substituent. So numbering will start from the substituent 1, 2, 3, 4 and 5. In that case, see 1 methyl is a substituent, 1 methyl, because the methyl position it can be at any point. So 1 methyl cyclopentane. This is the name of a compound. Parent name it is pentane and cyclic structure, that is why cyclo, and the compound substituent it is at 1 position. Now for example, there is suppose same is the structure of an cyclopentane. In case of an cyclopentane, we are having a methyl substituent at this position, same position, and we are having a double bond. Now one thing you remember, that in case of an priority we have written that the double bond it will have an higher priority. We cannot start numbering from this side 1, 2. We have to start a numbering. In this case numbering will start from a double bond. Double bond it will be always in position number 1 and 2, or it will be in any position, but the first number it will be considered. Like in this case we will not consider 2 alkene, we will consider 1 alkene, because double bond position it is located in carbon number 1 and carbon number 2. So 1, 2, 3, 4, 5. Our numbering cannot be like this also 1, 2, 3, 4, 5. We have to make a judgment, or we have to find out the closest route from to which we can reach the methyl. So the closest route to reach the methyl is 1, 2. And this position is also wrong, this numbering is also wrong 1, 2, because the double bond position we have to consider. Now double bond position we have considered. The name of the compound it will be as similar, but there will be only change. So the change will be of a numbering. So it will be 2 methyl cyclopentane, and there is a double bond in between carbon number 1 and 2. So here we can write 1 pentene, or pent 1 in. Both the names are correct. Now we will have an example from name to structure. Earlier we had an example of structure to the name. See, this is the name of a compound 3-amino-5-methyl hexanoic acid. Now in this case there is a chain of an hexane, we know that. So write firstly the carbons 1, 2, 3, 4, 5 and 6. So there are 6 carbon, and I will number the carbons. So I will number it from here 1, 2, 3, 4, 5, 6. Firstly write the substituents on it. You should know that carbon will have always valency of an 4. So always it will have a valency of an 4. So the structure can be written in this manner. Every carbon now it is having a valency of an 4. So firstly you write that. Now here we are having a substituent at number 5th position. So I will write the name of that substituent, that is methyl. After that 3 amino. So here I will write amino and hexanoic acid. So there are 6 carbon, but this hexanoic acid means it is having a carboxylic acid. So I will write here a carboxylic acid at the first carbon, because numbering will start always from this carbon. And remaining carbon replace the wherever the place is vacant, replace with an hydrogens. Now we will get a compound. This is our structure of a final compound. It can be written in this manner also. Instead of writing hydrogen separately, CH2, after that CH and NH2, after that again CH2, and after that CH and CH3 and again CH3. So this will be our final compound, but only you remember that the carbon should have a valency of 4. There should be no 3 valency or 2 valency or 1 valency. Always check the bonds of a carbon, it becomes always 4. Example number 2, name to structure. We are having a name of a compound that is 4-hydroxy-2-butanone. The chain of it is of an butane, so I will draw firstly the chain of an butane of an 4 carbons. At number 2, here is an one. It is having a ketonic functional group. So, and this functional group, ketonic functional group, it is at carbon number 2. 2-hydroxy. Sorry, 2-butanone. Now this is the structure of an 2-butanone. Now we have to add a 4-hydroxy at 4th position. So here it will be. Now check the valency of an each carbon. It should be always 4. There are 4 bonds. So here it will be H, 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 again H, again last carbon, again H. So we have fulfilled all the carbon valency 4. This carbon also it is having valency 4, 1, 2, 3. 2 bonds of an oxygen and 2 bonds from a carbon. So this structure can be written in this manner: CH3, C double bond O, CH2, CH3. Now the structure it is 2-hydroxy-2-butanone. Now the next example it is 6-cyano-3-oxo-4-heptenol. There are 4 complete different functional groups present in it. Here we can see it is an aldehyde, Al, it means aldehyde. Here it is E, it means it is an alkene. And that alkene it is at an 4th position. 3-oxo, it is a ketone, and 3-cyano, it is a nitrile functional group. When it is written in the prefix, it is written as a cyano. So cyano is 1, right? After that oxo is 1, double bond is 1, and aldehyde is 1. So there are 4 different functional groups in a given compound. Now we need to join it. The structure it is on a heptane. Basic structure it is on a heptane. So I will write 7 carbons. So I have written 7 carbons: 1, 2, 3, 4, 5, 6, 7. I will number it: 1, 2, 3, 4, 5, 6, 7. Now we will go one by one. Heptenol, it is a principal functional group. In this case it is an aldehyde. So it should be at carbon number 1 only. So it is at carbon number 1. Again a double bond location, it is at carbon number 4. So here it will be a double bond location, that is in carbon between carbon number 4 and 5. 3-oxo. So the carbon number 3 will have a ketonic functional group, and 6-cyano. So cyanide it will be present on the 6th number carbon. Now check the valency of each carbon. So here it is aldehyde. There are 2 bonds with this second carbon. So I will write CH2. There are 4 bonds with this carbon. In this carbon there are 3 bonds, so 1 hydrogen, and in this also there are 3 bonds plus 1 hydrogen. In this case again there will be 1 hydrogen, and in the last case there will be 3 hydrogen. So each carbon will have a valency of now 4. So this is the final structure of a compound. Thank you for watching the video. If you have any kind of a doubt, you can comment me in the comment box section. I will definitely answer the questions.